Hey, hi boys and girls. I'm back again with the second half of Tesla Battery Day. I've got a few things that I needed to say thank you for, and I also wanted to clarify a few of the questions that we got when I gave my little pitch. So first off, I'd like to thank you, Alex. Alex sent a note out to Elon, and it was kind of a nice note, and it caused or created quite a stir. So I wanted to thank you, Alex, with your tweet. Also, I want to make sure that everybody gets the opportunity to go and have a look at Sean Mitchell's Battery Day show. I really think it'd be a good idea if you went out there and looked at Ravi Kemba's presentation. I think he did a fabulous job. I don't see enough people looking at it, but if you're really interested in how batteries work, he did a much better job at showing how the whole battery is put together and all the processes associated with it. So please go out there and have a look at Sean Mitchell's show. So we had a bunch of questions that were asked, and like there were, I don't know, 1,500, I don't know, 2,000, a lot of them. Anyway, we went through and we took the four high flyers, and I'm going to address those. So one of the questions was, why is it that they're putting or trying to wick the heat away from the bottom of the battery instead of taking it to the hot top? Doesn't heat rise? Heat rises naturally in the world, in the atmosphere, but that's not the way batteries work. So heat distribution in a battery, it's going to travel to the negative substrate. So that's at the bottom, and that's what happens. Is so the heat's going to travel down the battery into the negative substrate, and then that's going to be directly attached to the cold plate. So that's why it's the better route to take than trying to cool from the sides, and you definitely don't want to cool from the top. I mean, that's going to be maybe one of the coolest places around. And not only that, that's where all the connectors and everything are. And then another question was, where did that casting come from? Well, 4 years ago, a company called Invocast came up and said, hey, can you have a look at our stuff and try and promote it amongst the automotive industry? We've had it here. We tried our best. We can't seem to get a hold of those guys anymore, but it's been here for 4 years, and I'm sure that if there's somebody out there from Invocast that could get back to us, that'd be great, because it's kind of like what I want to use on projects that we're developing, new product development projects that we're developing here at Munro. So I'd like to get more information on that, but the company's name was Invocast. And then there was a lot of questions about me saying epoxy versus structural adhesive. Both of these things are two-part glues as far as I'm concerned. And I can get rid of epoxy and I can get rid of structural adhesive. It doesn't really matter from a recycling standpoint. It's a piece of cake. So no big deal. I would have picked probably epoxy because I wanted something that was wicked strong, and I want to use it for crash worthiness. Epoxy is a good thing to use. Structural adhesive also has the same sort of characteristics. And by the way, it can be also not just structural adhesive, it can also be structural foam, which is what we use in a car a lot. So then the last thing that everyone wanted to know about was recycling. And there are many companies working on that currently. Most of them are going to use a chilling process. So you take the structural adhesive and the battery pack and whatnot, and you drop it into liquid nitrogen, you crush it, you make sure that there's an inert gas over the top of everything so that nothing can catch on fire. You grind it all up into small pieces, and then it goes into weirs and several different other different batches for separating the elements, and ultimately you wind up with lithium here, nickel there, and all the other, and cobalt in another one. So it's not the easiest thing in the world, but it's a whole lot easier and better than digging up thousands of square miles to try and extract the ingredients needed for making lithium-ion batteries. So the next one here, I have to thank you, Mr. Musk, for saying Sandy Munro understands engineering. It's very kind of you. I appreciate that. And it kind of leads me into what I want to talk about right now. So the process of getting from what might be a problem today to a solution tomorrow usually has something to do with thinking about the problem entirely differently. So you'll see a little PowerPoint slide showing a picture of a general aviation aircraft, and that general aviation aircraft is classified as unsafe by all insurance companies and everybody else. They all say, "Oh, that's unsafe." But in actuality, in working with Cirrus, we found that maybe the safe way to have a general aviation plane is to have a ballistic parachute. And that's precisely what Cirrus has. And that's why they dominate the marketplace, because they do have something that helps out. The aircraft that Cirrus produces with the ballistic parachute is really not much different when it comes to thinking of things in a different way than maybe these two products that you see up here. That up there is, on TV they call that the Smart Bomb. Really it's called the Paveway. And when we were working with Texas Instrument on the Paveway and also the Bunker Buster, many things were discussed, like Obi-Wan Kenobi's, or sorry, not Obi-Wan Kenobi, but Luke Skywalker dropping a bomb into a little teeny hole while he was flying along with the Force. In the United States, we don't need the Force. If you have that bomb right there, it'll drop right into a hole nicely, or a chimney, and blow up whatever's inside. But how to get there was a little inventive, because that doesn't have a rocket ship attached to it. It travels strictly on guiding itself using wind, using the air. So that's one thing. And then next to it is an engine I helped work on when I was with Ford Motor Company. Now, Ford Motor Company wanted to have an ultra-efficient 4-cylinder engine, gasoline engine. But if you try and increase the compression ratio, you have a tendency to blow the head off. So we developed an engine called a monoblock, which didn't have a cylinder head. By moving from what was commonplace to what's new or what's thought of in a different way, that's how you solve problems. And my last one is the Boeing 787. The 787 uses carbon fiber, and all of the people who understood airplanes know that carbon fiber, well, that just can't be done. It's too expensive. Did you know how much that is per pound? Blah, 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 on and on. But Munro was one of the first. We were two of us on a program where there was only 5 people on that program. And that was the start of the Boeing 787. And we worked all the way through on there and proved that, quite frankly, carbon fiber may be a little difficult to work with occasionally, but it's not the expense that you look at, it's what the outcome is going to be. And that's kind of like what Munro is really all about. How do we come up with outcomes that other people find challenging? And that's why people bring us onto their programs. So that brings us to the question of why 3-wheeled vehicles. So what I'm going to do is I'm going to talk about first principles and a little bit of history. So as you probably all know, Carl Benz invented the modern, or what was now to be called the modern automobile. And there's his picture right there, a picture of his vehicle. And you can see that it's a 3-wheeled car. He has kind of like a steering wheel and whatnot, but he went with 3 wheels. And the rationale behind that 3-wheeled vehicle was it's plane. That's basically, a plane means that I have 3 points of contact. It's an engineering term. So he had a plane, that's all you need. That's all you needed to have. And quite frankly, his wife was also a pioneer. So Bertha Benz, she took his little three-wheel car and went on the first all-woman road trip. Now, I just found out something that I didn't know, and that was that Bertha was kind of a strong-headed woman, and her husband said, oh, you got to leave that alone, and she went for her little trip on her own without anybody's permission. She figured that car is probably half mine, I'm going to take my half for a ride. And I like that kind of fortitude, that kind of inventive new way of thinking. And speaking of new thinking, Buckminster Fuller. Now, we don't hear his name much, but this guy was absolutely a genius in his day. And you look at that little car that he's got sitting up there, and you'll see that it has three wheels for one thing, but also that this is a lot more than just your average car. This has got lots of stuff going on inside of it. This was like the first RV or the first mini wagon, or sorry, station wagon that was on the universe. And this thing got quite a bit of attention. Unfortunately, World War II got a bigger set of attention. So we look at three-wheel vehicles and whatnot, and we say, well, yeah, but what's the future hold? I just want to tell you that George Jetson's car has three wheels. I don't want to, brag or anything, but watching George Jetson has had a great influence on me. So that's the first principles. But why am I really focusing my attention on three-wheel vehicles? Here it is. It weighs less. And if it weighs less, that means we don't beat up the roads as much. It weighs less, so that means you get better economy on your batteries. It weighs less, so that means that it's going to cost less. It's going to have lighter materials than everybody else. It's going to be easier to produce. It doesn't take up as much space. Space is a premium now, especially in urban areas. And I'm going to show you a little idea that our friends at Nobe have come up with. There's a lot of reasons why we need to conserve space. Usage. If you look right now, you find that most people are driving a giant car with one person in that car, and they're going to whatever place that they need to go to, trying to find space, using up road space, and quite frankly, usually choking, trying to get from point A to point B on an expressway. Efficiency. Three wheels are more efficient than four. Two is better, but that's a motorcycle, and I had plenty of those, and I can tell you for sure by the by the rocks in the seat of my pants that's not always a fun trip. Okay, after 3 motorcycles and about 8 accidents, I decided that I wasn't going to do that much anymore because I'm too old. So, but with a three-wheel vehicle, as long as it's safe, I can get ahead. So the next one's ecology. I don't want to use up all the materials on the planet to make a vehicle. And a three-wheel vehicle is going to have less components needed than a four-wheel vehicle. Energy uses is obvious. Energy is going to go down as rolling friction goes down and weight goes down. Cost to consumer is going to be less. You're going to spend less money on a three-wheel vehicle because basically 1/4 of the suspension is missing. So the cost of the consumer is going to go down quite a bit. Longevity. Because we're looking at a problem that can be solved, longevity of the vehicle is also going to be something that you're going to see more and more of if we can get to a three-wheel vehicle. And then we talk about safety. So there's a thing called FMVSS. That is the government's regulations on four-wheel vehicles that basically travel on expressways, and you're looking at crash worthiness and things like that. Now, am I going to make my vehicles FMVSS classified? And the answer is probably not, because if I do that, then I'm going to increase the rate, increase the cost, increase the amount of materials needed, and on and on. I'm looking at a vehicle that's going to be used mostly in urban areas, and I believe that like Europe and like China, and like Japan and like every other country basically in the world, because of the way things are going right now, there's going to have to be 2 classes of cars. And if we think about it, General aviation is the big airplane, big by standards of small aircraft. But at the end of the day, that aircraft is not the only type that the FAA has certified. There's sport light and ultralight. And those don't follow the same rules as what's happening in general aviation because they're used in an entirely different way. And that's what I believe is going to happen with the government shortly. They're going to have to go in and classify two different kinds of vehicles because, as you probably know, very few people are making sedans. You can't make money on them. And that's kind of what's going on. So I'm going to say that maybe our vehicles won't be as robust as a standard car, but it'll be a way more safe than a motorcycle. So I'd rather not be classified as a three-wheeled motorcycle. Now, we have a couple of our customers. One of them is Arcimoto. It's the Fun UV. And it is an off-road kind of a product, but you can also ride it on-road, like a motorcycle. This vehicle that you're looking at has lean design, which is our trademark kind of software, and it's also got frugal engineering. And why is that? Because we have to make it so that everybody can afford it. Everybody needs one of these things that's going to go from point A to point B, and I think that this is a great way to make things happen. And then we've got, on the next slide, Aptera. So one of the things I like about Aptera is that they've changed the paradigm. They don't care about plugs. They don't care about electricity. That's to them no problem because they're basically running 100% on solar. By the way, one of the things that I did here is that FMVSS standards have been applied to this vehicle, and probably the one that would be a killer for most cars is the SORB, and that SORB test would be no problem for this car because you would just pull off the wheel and it really doesn't intrude into the car at all. So an inventive way of getting around some of the issues that might be associated with getting into the three-wheeled motor vehicle business. So the next slide you see is the Nobe, the Blue Beauty that we got in here. So I didn't get a chance to talk about was the Lillian. The Lillian's a convertible, and we're going to design the convertible first. And the reason for that is because I want it structurally sound as a convertible, and then we're just going to carry the extra weight or the extra safety and put it into the sedan. Now, as we move through the sedan and we look at the little parts that are going to go on inside, you can see that this is very, very similar to what would be done if we were making a full-size normal car. We're not skimping and we're not cheating, but people need to know that this is safe. So let's talk a little bit about the unfortunate history associated with Nobe in their home country of Estonia. So if we look at this slide, you can see that it's a little shop with a couple of cars, and you can see in the back that that's the Lillian being built, the convertible being built. The next slide shows why we're working with them. They were totally burned out. Everything burned up, and so now they need some more support, some more help. They've come to the United States, and quite frankly, I'm welcoming them with open arms because I really feel that they've got a good product. I recommend that you type in Nobe and go and have a look at the videos that you'll see on their website. Now, what is Munro going to do that's going to be different than what Nobe has already done? So the first thing is that I'm going to be putting airbags inside their car. The airbags are going to come out of the seat belt, like what we did on the left-hand picture, or the right-hand picture that you're seeing. That's the seat that we designed for aircraft. Now, our aircraft, the Paradigm, never got it into production because, quite frankly, we brought it out in 2008 and the banks all melted. So we created that to be a substitute for the normal GA kind of aircraft. And in that aircraft, we were bound and determined that we were going to have airbags. And so that's precisely that airbag that we were working with a company on. That's exactly what we're putting into the Nobe vehicle. So it has, and then if we start talking about how people claim, you know, the three-wheel vehicle is unsafe. Now, the vehicle being unsafe can be a lot of different reasons. From a crashworthiness standpoint, we are going to put crushed cans and things like that, so there'll be a minimum amount of intrusion. But we also know that everyone talks about little three-wheel vehicles that flip over. That happens for two reasons. One, the center of gravity is too high, and two, the wheels are too close together, and and they really, really don't have any way of doing anti-roll control. When we are working with this car will have air suspension, which means I get anti-roll control. So we're also going to be putting in anti-lock brakes and stability control. So with these two features, we've got most everything that you're going to have or going to want to have in a standard car. And as far as spinning out and things like that, that's not going to happen. Now, there's always the big dilemma with these smaller vehicles, and that is, what are we going to do when we go golfing? So I just want to let you know that we are going to be adding. You can put your golf clubs into the Nobe, 2 sets, and that picture you see, it says 2 sets of big boy golf clubs. That's because the guy that a minor is 1 set. I don't golf, but they were purchased for me by my ex-wife, and they're normal size golf clubs. I'm 5'10", and the other ones they're kind of like golf clubs for a monster. Okay, so we call him Big John, and he is big, 6'8" or something like that, and heavy enough that he'll make the car sag on one side, I'm sure. So now I want to get into the last little bit, and that is space. I talked about space, and Nobe has come up with a fabulous idea. Whether you're in Los Angeles or New York City, the new word is going to go, let's go vertical. So you drive up, you click in, and then up the wall you go. So no more parking problems, no more issues associated with just trying to find a parking spot if you've got that stuff hanging on the walls. So what's that good for? Well, it's good for the guy who owns the car, but what happens if you turn that into a parking garage or a parking lot that the city can actually put up a little something on the walls? Every city is looking for, how do I attract new revenue? This vertical parking, that's going to be the amazing new way of generating wealth inside cities, probably in alleys and whatnot, where they can't make any money. In fact, they're a loser, because an alley, of course, is just for garbage trucks and whatnot. Now it would be something where you could park vertically. So here's the deal. I'm looking for investors in Nobe. This is not fooling around time. And I know everybody's going to say things like, "Oh, I just lost all this time looking at an investor's document." But here's the real deal, folks. We need to move a lot faster to get into the age that we need to get into in order to basically save the planet and save space and cut down the cost of road repairs, and on and on and on and on. Now's the time for me to make a move in a new and more exciting direction, but we need investors to help us out there. So if you think that anything you saw here today was worthwhile, I'd appreciate it if you could send me a note. That's SMUNRO@LEANDESIGN.com. That's smunro@leandesign.com. And by the way, boys and girls, I got the box here with my new toy in it. Okay, this is the exciting new way we're going to have for making cars, electric cars anyway, a lot more exciting and a lot faster. Inside of here, we'll open this up in a couple of days, and we'll let you know what we find. But I think what we've got here is the fountain of youth for electric vehicles, or at least electric motors. So anyway, stay tuned. See you again. Tip those tip those cashiers, and have yourself a great day. Thank you for watching, and remember to go and see Sean Mitchell. Bye now.